our group will present our data science project, where we use probability and data to analyze and make predictions about natural outcomes. Next slide. I'm Jherrie, and here with me are Erin, Ryan, Marc, Kim, and Jastine. Our objective in this project was to analyze industrial outcomes and see if we could make any predictions. We collected and recorded data, analyzed frequency, and created visualizations to patterns and trends.
We use a 20-sided die, rolling it 100 times to collect our data. Each outcome was recorded in Excel and then organized for further analysis using Python. This helps us systematically track each roll and prepare for deeper analysis.
After recording each dice roll, we organized the results into a frequency table. This table helped us how often each number from 1 to 20 appeared. This was our starting point for identifying trends in our dataset.
We visualized the data to highlight key outcomes. Number 17 appeared the most with 9 occurrences, while 4 and 12 were the least frequent, showing up only twice. Our average frequency across all numbers was about 5.35, which gave us a benchmark for comparison.
Based on these outcomes, we formed a hypothesis. Numbers that showed up more frequently in past rolls might appear more often in future rolls. So, numbers like 17, 5, 1, and 19 became our focus for prediction. We identified this pattern to see if they could influence practical application in the gameplay.
Now, you might be wondering, with all of this data, what are the practical applications? Well, this analysis can be useful in games like Dungeons and Dragons, especially for the Dungeon Master, because knowing common role outcomes can help the Dungeon Master balance encounters and skill checks. Since there are numbers more likely to be rolled by the players, then you can set the level to reach that certain point that it feels fair for the players, but also not too hard for them to reach those goals. It adds a layer of strategy and uh, much more depth overall. Next slide, please. We also have the practical application in using this sort of information for board game designs. Many board games that involve dice utilize the ability of the dice to provide chance and luck aspect to games. But when we look at something like the example of Catan, where board game designers were able to use the frequency of certain outcomes to balance their game, we can also apply this with future games if you're planning to make with the amount of data that we've collected.
However, there are some limitations that we must recognize. Each dice roll is an independent random event, so prior outcomes don't guarantee the future results. A larger dataset might provide more accurate insights, but randomness still plays a big role here.
To wrap up, our analysis helped us better understand the randomness of each dice roll and gave us insight into using data science to study probabilities. However, while patterns appeared, they can't assure success in future rolls.
Thank you for listening to our presentations. We hope you enjoyed it, and we're open to any questions you have.